100 Facts About Chemistry to Fall Asleep To. Let's begin our journey through the gentle world of chemistry, where everything around us tells a quiet story of atoms and bonds, of transformations that happen slowly, peacefully, all the time. Fact 1. Imagine, if you will, that everything you can see, touch, and feel is made of incredibly tiny particles called atoms. These atoms are so small that a single grain of sand contains more atoms than there are grains of sand on all the beaches of Earth. It's a peaceful thought, really, that we're surrounded by this invisible architecture, smaller than we could ever see, holding everything together in perfect harmony. Fact 2. Now, here's something wonderful to consider. The atoms in your body aren't new. They've been here for billions of years, recycling through stars, oceans, mountains, and living things. The carbon atoms in your hand right now might once have been part of a dinosaur, or an ancient tree, or drifting peacefully through a nebula in space. You are, quite literally, made of stardust that has been gently rearranged over eons of time. Fact 3. These atoms rarely exist alone in nature. They prefer company, bonding together to form molecules, like friends holding hands in the dark. The water you drink, for instance, is made of molecules so simple and elegant, just two hydrogen atoms bonded to one oxygen atom. We call it H2O, and it's perhaps the most important molecule for life on Earth. Each water molecule is shaped like a gentle V, with the oxygen sitting at the vertex and the hydrogen atoms spreading out like open arms. Fact 4. Chemistry, at its heart, is about transformations. When you light a candle and watch the flame dance softly in the darkness, you're witnessing a chemical reaction called combustion. The wax of the candle, made of long chains of carbon and hydrogen atoms, meets oxygen from the air, and together they transform into carbon dioxide and water vapor, releasing light and warmth as they go. The flame you see is actually glowing gases, heated to such temperatures that they emit their own gentle light. It's a transformation that's been bringing comfort to humans for thousands of years. Fact 5. Let's drift now to the air you're breathing right now, entering and leaving your lungs in a peaceful rhythm. The Earth's atmosphere is about 78% nitrogen and 21% oxygen, with tiny amounts of other gases making up the rest. That oxygen you breathe in, each molecule made of two oxygen atoms bonded together, travels deep into your lungs where it meets your blood. There, in a beautiful molecular exchange, the oxygen attaches to iron atoms within a protein called hemoglobin, and gets carried throughout your body. Fact 6. The hemoglobin in your blood is what makes it red. It's the iron atoms at the center of each hemoglobin molecule, holding oxygen like a precious gift. Without those iron atoms, your blood couldn't carry oxygen efficiently, and that deep red color you associate with life itself simply wouldn't exist. Fact 7. Here's a soothing fact about the number of elements that exist. There are 118 confirmed elements on the periodic table, though only about 90 occur naturally on Earth. The rest have been created by scientists in laboratories, existing for just fractions of a second before transforming into something else. Each element is defined by the number of protons in its nucleus. Hydrogen has 1, helium has 2, carbon has 6, oxygen has 8. It's a simple counting system that creates all the magnificent diversity of matter we see around us. Fact 8. And speaking of hydrogen, it's the most abundant element in the universe, making up about 75% of all normal matter. It's the simplest element, with just one proton and one electron, yet it's fundamental to everything. In the cores of stars, hydrogen atoms fuse together to create helium, releasing the energy that makes stars shine. Our own sun is performing this gentle alchemy right now, as it has for about 4.6 billion years, turning hydrogen into helium and bathing our planet in warm light. Fact 9. Let's return to Earth for a moment, to the gentle process of rust forming on iron. When iron meets oxygen and water, they slowly react together to form iron oxide, what we call rust. This reaction happens peacefully, gradually, over days and months and years. The reddish-brown color of rust is simply iron atoms bonded to oxygen atoms in a particular arrangement. It's decay, yes, but it's also transformation. The iron returning to a form more similar to how it existed in the earth before humans ever extracted and refined it. There's something meditative about that slow return, that gentle surrender to oxidation. As you settle deeper into rest, consider this. Every breath you take, every thought you think, every movement you make is guided by chemistry. The neurons in your brain communicate through chemical messengers called neurotransmitters, floating across tiny gaps between cells. Your muscles move because of chemical reactions that release energy stored in molecules. Even your dreams tonight will be shaped by the gentle dance of molecules in your sleeping brain, choreographed by billions of years of chemical evolution. Fact 10. Let's talk about something you might not think about very often, the salt in your kitchen. Table salt, or sodium chloride, is made of two elements that on their own would be quite dangerous. Sodium is a soft, silvery metal that reacts violently with water, bursting into flames if you drop it in. Chlorine is a toxic yellow-green gas that was actually used as a weapon in World War I. But when these two elements come together, they form a chemical bond so stable, so perfect, that they create something we sprinkle on our food every day. It's one of chemistry's beautiful paradoxes: danger plus danger can equal safety. Fact 11. Speaking of bonds, atoms connect to each other by sharing or transferring electrons, those tiny particles that orbit around the nucleus. Think of electrons as the currency of chemistry. When atoms share electrons, we call it a covalent bond. When one atom gives electrons to another, it's an ionic bond, like the one in salt. These bonds are what hold molecules together, and they're surprisingly strong. The bonds in a single strand of spider silk, for instance, are stronger pound for pound than steel, all because of how the atoms are arranged and connected. Fact 12. Now let's drift to something sweet. When you taste sugar dissolving on your tongue, you're experiencing a physical change, not a chemical one. The sugar molecules aren't breaking apart or transforming, they're simply separating from each other and mixing with the water in your saliva. Each sugar molecule, called sucrose, stays intact. It's made of carbon, hydrogen, and oxygen atoms arranged in a specific ring structure. Your body will break those bonds later, during digestion, but on your tongue, the sweetness you taste is just those intact molecules interacting with receptors. Fact 13. Here's something that connects us to the very beginning of chemistry as a science. For thousands of years, people believed in something called phlogiston, an invisible substance they thought was released during burning. When wood burned, they believed phlogiston escaped into the air. It wasn't until the late 1700s that a scientist named Antoine Lavoisier proved that burning actually consumes oxygen from the air. He showed that matter is neither created nor destroyed in chemical reactions, only transformed. This is called the law of conservation of mass, and it's one of the fundamental truths of chemistry. Everything that exists now has always existed, just in different forms. Fact 14. Let's think about diamonds for a moment, those precious stones that symbolize eternity. A diamond is pure carbon, the same element that makes up the graphite in a pencil. The only difference is how the carbon atoms are arranged. In a diamond, each carbon atom bonds to 4 other carbon atoms in a rigid, 3-dimensional structure that makes it the hardest natural material on Earth. In graphite, the carbon atoms form flat sheets that slide over each other easily, which is why pencils leave marks on paper. Same element, completely different properties, all because of arrangement. Fact 15. When you smell fresh bread baking, or coffee brewing, or flowers blooming, you're detecting molecules that have evaporated into the air and traveled to receptors in your nose. Smell is chemistry made personal. Those aroma molecules have specific shapes that fit into receptor proteins like keys into locks. Your brain interprets these molecular shapes as scents. A rose smells like a rose because of hundreds of different molecules working together, each one a unique combination of carbon, hydrogen, and oxygen atoms arranged in its own special way. Fact 16. Here's a gentle fact about temperature. What we call heat is really just atoms and molecules moving. In hot water, the water molecules are vibrating and moving around quickly. In ice, those same molecules are locked in place, barely moving at all, arranged in a crystalline structure. Temperature is simply a measure of this molecular motion. At a temperature called absolute zero, which is negative 273.15 degrees Celsius, all molecular motion would theoretically stop completely. It's the coldest possible temperature, a point of perfect stillness that we can approach but never quite reach. Fact 17. Let's drift to the ocean now, to the salt water that covers most of our planet. Ocean water is about 3.5% dissolved salts, mostly sodium chloride but also magnesium, calcium, and potassium compounds. These salts have been accumulating in the ocean for billions of years, washed down from rocks and soil by rain. The ocean is essentially a giant chemical solution, and it's remained remarkably stable in its composition for millions of years. Life itself began in this salty water, and the fluid inside your cells still has a similar salt concentration to the ancient seas where our earliest ancestors evolved. Fact 18. When autumn leaves change color, you're witnessing chemistry in slow motion. The green you see during summer comes from chlorophyll, the molecule that captures sunlight for photosynthesis. But there are other pigments in leaves too, carotenoids that are yellow and orange, and anthocyanins that are red and purple. During summer, the green chlorophyll is so abundant it masks these other colors. As days get shorter and temperatures drop, trees stop producing chlorophyll, and it breaks down. The other pigments were there all along, patiently waiting, and now they finally get their moment to shine before the leaf falls gently to the ground. And so our journey continues, through transformations both sudden and slow. Fact 19. Let's think about something as simple as a glass of water sitting on your nightstand. Even though it looks perfectly still, there's constant motion happening at the molecular level. Some water molecules at the surface are evaporating, escaping into the air as water vapor. At the same time, water molecules from the air are condensing back into the liquid. When these two processes happen at the same rate, we call it equilibrium. It's a dynamic balance, like a perfectly choreographed dance where molecules are always moving but the overall amount of water stays the same. Chemistry is full of these quiet balances, happening all around us without any effort on our part. Fact 20. Now, here's something beautiful about the element gold. Gold is so unreactive, so chemically stable, that gold objects buried for thousands of years look almost exactly as they did when they were first made. Ancient Egyptian gold jewelry still gleams after millennia underground. This happens because gold atoms don't easily form bonds with other elements. They're content as they are, unbothered by oxygen or moisture or time. It's this chemical stability that makes gold so valuable, not just its rarity or beauty, but its ability to remain unchanged while everything around it transforms. Fact 21. When you see a firefly glowing softly in the summer night, you're watching one of nature's most elegant chemical reactions. Inside the firefly's body, a molecule called luciferin reacts with oxygen in the presence of an enzyme. This reaction releases energy in the form of light, with almost no heat produced. We call this bioluminescence, and it's incredibly efficient. While a regular light bulb wastes most of its energy as heat, the firefly's chemical light is nearly 100% efficient. It's chemistry creating light from the inside out, a gentle glow powered by molecules. Fact 22. Let's drift to the concept of pH, which measures how acidic or basic a solution is. The scale runs from 0 to 14, with 7 being neutral. Your stomach acid has a pH around 2, acidic enough to break down food and kill bacteria. Your blood, on the other hand, maintains a very tight pH of about 7.4, just slightly basic. Your body works constantly to keep your blood pH in this narrow range, because even small changes can be dangerous. It's a delicate chemical balance maintained by your lungs, kidneys, and buffer systems in your blood. All of this happens automatically, quietly, keeping you alive without you having to think about it even once. Fact 23. Here's something about the air again, but different this time. Carbon dioxide makes up only about 0.04% of Earth's atmosphere, just 0.04%. Yet this tiny amount is crucial for life. Plants take in carbon dioxide and use energy from sunlight to convert it into sugars and oxygen through photosynthesis. The oxygen they release is what we breathe. The sugars they make become food for nearly every living thing on Earth. So this trace gas, this tiny fraction of our atmosphere, is the foundation of the entire food chain. Sometimes the smallest amounts make the biggest difference. Fact 24. When milk goes sour, it's because of a chemical change caused by bacteria. These tiny organisms feed on lactose, the sugar in milk, and convert it into lactic acid through a process called fermentation. As the lactic acid builds up, it causes the proteins in milk to clump together and the milk to taste sour. But this isn't always a bad thing. Yogurt and cheese are made through controlled versions of this same process. The difference between spoilage and food production is sometimes just a matter of control and intention. Chemistry in the hands of different creatures, working toward different ends. Fact 25. Let's think about soap for a moment, that everyday miracle. Soap molecules are special because they have two different ends. One end loves water and is attracted to it. The other end hates water but loves oils and grease. When you wash your hands, the oil-loving ends grab onto the dirt and oils on your skin, while the water-loving ends stay pointed outward. When you rinse, the soap molecules get carried away by the water, taking the dirt with them. It's a simple molecular design that's been cleaning humanity for thousands of years. Chemistry making the invisible visible, the dirty clean. Fact 26. Here's a fact about time and chemistry. Some chemical reactions happen in fractions of a second, like the explosion of gunpowder or the flash of a camera. Others take millions of years, like the formation of fossil fuels deep underground or the slow growth of stalactites in caves. But most of the chemistry around you happens at a human pace. Bread rises over an hour. Fruit ripens over days. Concrete hardens over weeks. There's something comforting about that, chemistry working on timescales we can understand, witness, and appreciate. Fact 27. When you strike a match, you're starting a chain reaction. The friction generates enough heat to trigger a chemical reaction in the match head, which contains sulfur and potassium chlorate. This initial reaction produces enough heat to ignite the wood, which then burns on its own as long as oxygen is available. It's a tiny example of activation energy, the push needed to get a reaction started. Many reactions need this initial energy boost, like rolling a ball over a hill. Once it's over the top, it continues on its own. The match strike is chemistry's gentle nudge. We move forward now, deeper into the molecular world. Fact 28. Let's talk about something you encounter every single day, plastic. Most plastics are polymers, which means they're made of long chains of repeating molecular units, like beads on a string that goes on and on. A single plastic bottle might contain chains with thousands of repeating units. These chains can be flexible or rigid depending on how they're arranged and what else is added to them. The word polymer comes from Greek words meaning many parts, and that's exactly what they are. Many small molecules bonded together into something much larger, much stronger than any individual piece could be alone. Fact 29. When you crack open a cold soda and hear that satisfying hiss, you're releasing carbon dioxide that was dissolved in the liquid under pressure. Cold liquids can hold more dissolved gas than warm ones, which is why cold soda is fizzier than warm soda. The bubbles you see rising aren't air, they're pure carbon dioxide escaping from the liquid and returning to its natural gaseous state. Each bubble is a tiny pocket of molecules that were squeezed into solution at the factory, and now they're finally free. It's chemistry you can hear, see, and taste all at once. Fact 30. Here's something about copper that you might notice if you pay attention. When copper is freshly polished, it has a warm, reddish-orange glow. But leave it exposed to air and moisture, and over time it develops a green coating called patina. This is copper carbonate, formed when copper reacts slowly with oxygen and carbon dioxide in the air. The Statue of Liberty is covered in this green patina. Underneath, she's still copper, but she's wearing a coat of chemistry that's built up over more than a century. It's not decay exactly, more like aging, a natural transformation that actually protects the metal underneath from further corrosion. Fact 31. Let's drift to something sweet again, honey. Honey is one of the only foods that never spoils. Archaeologists have found pots of honey in ancient Egyptian tombs that are over 3,000 years old and still perfectly edible. This happens because honey is a supersaturated sugar solution with very little water, and it's naturally acidic. Bacteria need water to grow, and they can't survive in honey's high sugar, low water, acidic environment. Bees have essentially created a chemical preservation system through the way they process nectar, removing water and adding enzymes. It's food storage perfected by evolution, sealed in chemistry. Fact 32. When you see a cut apple turn brown, you're watching oxidation in action. The cells in the apple contain enzymes and compounds called polyphenol. When you cut the apple, you break the cells open and expose these chemicals to oxygen in the air. They react to form brown-colored compounds called melanins, the same type of pigment that colors human skin. It's the apple's wound response, a chemical reaction triggered by damage. You can slow this browning by adding lemon juice because the citric acid interferes with the enzymes. Chemistry can be reversed, slowed, or redirected by other chemistry. Fact 33. Here's a fact about crystals and how they form. When you dissolve salt or sugar in hot water and then let the water cool slowly, crystals can form as the solution becomes supersaturated. The molecules arrange themselves in repeating, geometric patterns because that's the lowest energy configuration. It's the most stable, most comfortable arrangement for them. Each crystal is like a molecular city with a perfect grid system, every atom in its proper place. Snowflakes are ice crystals, each one unique because of the specific path it took through the atmosphere, but all following the same hexagonal pattern that water molecules prefer when they freeze. Fact 34. Let's think about something invisible but essential, vitamin C, also known as ascorbic acid. Humans are one of the few mammals that can't produce vitamin C in our own bodies. We lost that ability millions of years ago, so we have to get it from our food. Vitamin C is a simple molecule made of just 6 carbon atoms, 8 hydrogen atoms, and 6 oxygen atoms, but it's crucial for producing collagen, healing wounds, and supporting your immune system. Without it, sailors used to develop scurvy on long voyages. The cure was citrus fruits, though they didn't understand the chemistry at the time. They just knew the fruit worked, that something in those lemons and limes kept them alive. Fact 35. When bread bakes, chemistry fills your kitchen with that wonderful aroma. The heat causes the proteins and sugars in the dough to undergo something called the Maillard reaction, named after the French chemist who first described it. This isn't burning, it's a complex series of reactions between amino acids and sugars that creates hundreds of different flavor and aroma compounds. The same reaction gives grilled meat its flavor, toast its golden color, coffee its richness. It's one of the most important reactions in cooking, turning raw ingredients into something delicious through heat and time and chemistry. Fact 36. Here's something about the metal aluminum. It's the most abundant metal in Earth's crust, making up about 8% of it. But you never find aluminum by itself in nature. It's always bonded to other elements in minerals like bauxite. It takes a lot of electrical energy to separate aluminum from its ore, which is why aluminum wasn't commonly used until the late 1800s when electricity became available. Before that, aluminum was more precious than gold. Napoleon III once had a set of aluminum cutlery that was reserved for his most honored guests, while everyone else used gold and silver. It's funny to think about, a metal that's now everyday and disposable was once rare and treasured. And so the chemistry continues, in things both common and extraordinary. Fact 37. Let's drift to the ocean again, but this time to think about shells. Seashells, coral, and pearls are all made primarily of calcium carbonate, the same compound found in limestone and marble. Marine creatures extract calcium and carbonate ions from seawater and combine them into solid structures, building their homes and skeletons one molecule at a time. When these creatures die, their shells accumulate on the ocean floor. Over millions of years, layer upon layer, they compress into limestone rock. The white cliffs of Dover in England are made almost entirely of ancient seashells. Mountains built from the chemistry of tiny sea creatures, slowly, patiently, over eons. Fact 38. When you light a piece of paper on fire and watch it burn, the paper seems to disappear, turning into ash and smoke. But remember Lavoisier's law, matter isn't destroyed. The carbon and hydrogen in the paper combine with oxygen from the air to form carbon dioxide and water vapor, which float away invisibly. The ash left behind is mostly minerals that were in the paper but couldn't burn. If you could capture all the gases and weigh everything together, the mass before and after would be exactly the same. Nothing was lost, only transformed and scattered. Chemistry is conservation dressed up as change. Fact 39. Here's something about the ice in your freezer. Ice is actually less dense than liquid water, which is unusual. Most substances are denser in their solid form than their liquid form. But when water freezes, the molecules arrange themselves in a hexagonal crystal structure with a lot of empty space between them, kind of like a molecular honeycomb. This is why ice floats, and why pipes burst when water freezes inside them. It's also why lakes freeze from the top down, creating an insulating layer that lets fish survive underneath through the winter. One quirk of water's chemistry makes winter survival possible for countless organisms. Fact 40. Let's talk about glass for a moment. Glass is technically not a solid, it's a supercooled liquid, or more accurately, an amorphous solid. When you melt sand, which is mostly silicon dioxide, and then cool it quickly, the molecules don't have time to arrange themselves into a crystal structure. They freeze in a disordered, liquid-like arrangement. This is why glass is transparent and why old windows are sometimes thicker at the bottom, though that's actually from the manufacturing process, not from glass flowing over centuries. Still, glass exists in this in-between state, neither truly solid nor liquid, a frozen moment of disorder preserved in time. Fact 41. When your muscles feel sore after exercise, that's partly due to lactic acid building up in your muscle tissue. During intense exercise, your muscle cells need energy faster than oxygen can be delivered to them. So they switch to a process called anaerobic respiration, which produces energy without oxygen but creates lactic acid as a byproduct. This lactic acid lowers the pH in your muscles and contributes to that burning sensation. Once you rest, your body clears the lactic acid away and uses it as fuel elsewhere. It's your body's backup energy system, chemistry stepping in when the usual pathways can't keep up. Fact 42. Here's something about the color blue in nature. Blue is actually one of the rarest colors in the natural world. Most blue things you see, like blue jays or morpho butterflies or blue eyes, aren't blue because of blue pigments. They're blue because of the physical structure of their surfaces, which scatters light in a way that reflects blue wavelengths back to your eyes. True blue pigments are extremely rare. The ancient Egyptians were among the first to create a synthetic blue pigment, made from calcium, copper, and silicon heated together. They valued it so highly it was used in the burial mask of Tutankhamun. Chemistry giving us colors that nature kept hidden. Fact 43. When you smell rain, that distinctive earthy scent, you're detecting a compound called geosmin. It's produced by soil bacteria called actinomycetes, and humans are incredibly sensitive to it. We can detect geosmin at concentrations as low as 5 parts per trillion. That's like detecting a single drop in 200 Olympic-sized swimming pools. Rain releases geosmin from the soil into the air, along with oils that plants secrete and that collect on rocks. That fresh rain smell is a complex mixture of chemistry released from the earth, and our noses have evolved to be exquisitely attuned to it, perhaps because rain historically meant water and survival. Fact 44. Let's think about caffeine, that molecule that helps so many of us wake up in the morning. Caffeine is an alkaloid, a bitter compound that plants produce as a natural pesticide. It's toxic to many insects. But in humans, in small amounts, caffeine blocks receptors in our brain that normally receive a molecule called adenosine. Adenosine builds up during the day and makes us feel tired. When caffeine blocks its receptors, we feel more alert. The effects are temporary, of course. The caffeine gets metabolized, the adenosine eventually finds its receptors, and we need another cup. It's a molecular game of musical chairs happening in your brain every time you drink coffee or tea. Fact 45. Here's a fact about the northern lights, those beautiful curtains of color that dance across polar skies. They're caused by chemistry high in the atmosphere. Charged particles from the sun, carried on the solar wind, collide with oxygen and nitrogen molecules in Earth's upper atmosphere. These collisions energize the molecules, and when they release that energy, they emit light. Oxygen produces green and red light, nitrogen produces blue and purple. The colors depend on which molecules are hit and at what altitude. It's chemistry on a massive scale, painting the sky with light, powered by the sun and guided by Earth's magnetic field. The story of chemistry unfolds in layers, in time, in light and darkness. Fact 46. Let's think about charcoal for a moment, that black substance used for grilling and filtering water. Charcoal is almost pure carbon, made by heating wood in the absence of oxygen. This process, called pyrolysis, drives off water and volatile compounds, leaving behind a porous carbon structure. What makes charcoal special is all those tiny pores. They create an enormous surface area. A single gram of activated charcoal can have a surface area of over 3,000 square meters, about half a football field. This huge surface area is why charcoal is so good at adsorption, trapping molecules in its microscopic tunnels and pockets. It's carbon transformed into a molecular sponge. Fact 47. When you peel an onion and your eyes start to water, you're experiencing chemistry as defense. Onions store sulfur compounds in their cells. When you cut an onion, you break those cells open and release enzymes that convert those sulfur compounds into a volatile gas. This gas drifts up to your eyes where it reacts with the water in your tears to form sulfuric acid. Your eyes detect this irritation and produce more tears to wash it away. The onion didn't evolve this defense for humans, of course. It's protection against insects and animals that might want to eat it. We just happen to be sensitive to the same chemical warfare. Fact 48. Here's something peaceful about helium, that gas that makes balloons float and voices sound funny. Helium is the second most abundant element in the universe, but it's quite rare on Earth. That's because helium atoms are so light and unreactive that they simply float up through our atmosphere and escape into space. The helium we do have comes from deep underground, produced by the radioactive decay of uranium and thorium over millions of years. Alpha particles, which are really just helium nuclei, get trapped in natural gas deposits. So when you fill a balloon with helium, you're releasing atoms that were born from the slow decay of radioactive elements deep in the earth. Ancient chemistry, set free to float away. Fact 49. Let's drift to something you might have in your medicine cabinet: aspirin. Acetylsalicylic acid, its chemical name, is derived from compounds found in willow bark. People have been using willow bark to relieve pain for thousands of years, long before anyone understood the chemistry. In the late 1800s, chemists at Bayer created a synthetic version that was easier on the stomach. Aspirin works by blocking an enzyme called cyclooxygenase, which your body uses to make molecules that cause inflammation and pain. It's a small molecule interrupting a cascade of chemical signals, bringing relief through molecular interference. Sometimes chemistry is about stopping reactions, not starting them. Fact 50. When you watch a candle flame, you might notice it's not all the same color. The base of the flame is blue, while the tip is yellow or orange. This is because different parts of the flame have different temperatures and different chemistry happening. The blue part at the bottom is where combustion is most complete, where there's plenty of oxygen and the carbon in the wax is burning directly to carbon dioxide. The yellow part higher up is where tiny particles of unburned carbon are heated until they glow, giving off that warm light. The flame is a gradient of chemistry, each layer telling a story about heat, oxygen, and combustion. Fact 51. Here's something about the metal silver. Silver is the best conductor of electricity and heat of any metal. Electrons flow through silver more easily than through any other element. It's also highly reflective, which is why mirrors used to be made by coating glass with silver. But silver has one weakness: it tarnishes when exposed to sulfur compounds in the air, forming a dark layer of silver sulfide. This is why silver jewelry needs polishing. The silver itself isn't damaged, just covered with a thin layer of chemistry. Polish it away and the bright metal underneath is unchanged, patiently waiting beneath its tarnish. Fact 52. Let's think about yeast, those tiny single-celled fungi that have been humanity's partners for millennia. When yeast cells consume sugar, they break it down in a process called fermentation, producing alcohol and carbon dioxide as waste products. In bread dough, the carbon dioxide gets trapped in the gluten network, making the dough rise. In beer and wine, it's the alcohol we're after. The same chemistry, the same organism, the same process, just different applications. Yeast has been performing this alchemy for us for at least 10,000 years, turning grain into bread and fruit juice into wine, one molecule of sugar at a time. Fact 53. When you see a rainbow after a storm, you're seeing white light separated into its component colors by water droplets in the air. But there's chemistry hidden in those colors too. Different colored photons have different amounts of energy. Violet light has the most energy, red has the least. Plants use primarily red and blue light for photosynthesis, reflecting green light back to us, which is why plants look green. Your eyes have 3 types of color receptors, each containing a protein that changes shape when hit by specific wavelengths of light, triggering a chemical signal to your brain. Vision itself is chemistry, turning light into electrical impulses through molecular transformations. Fact 54. Here's a general fact about pearls. A natural pearl forms when an irritant, like a grain of sand, gets trapped inside an oyster shell. The oyster coats it layer upon layer with nacre, which is made of calcium carbonate and proteins. The calcium carbonate forms in a specific crystal structure called aragonite, arranged in thin, overlapping layers like tiles on a roof. This structure, combined with the organic proteins between the layers, gives pearls their unique luster and iridescence. It takes years for a pearl to form, the oyster patiently secreting chemistry around the irritant, transforming annoyance into beauty one molecular layer at a time. And so we continue through the quiet transformations all around us. Fact 55. Let's talk about something that happens in your body right now, even as you rest. Your cells are constantly producing a molecule called ATP, or adenosine triphosphate. ATP is like a rechargeable battery for your cells. It stores energy in the bonds between its phosphate groups. When your cells need energy for any task, whether moving a muscle, sending a nerve signal, or building a protein, they break one of those bonds in ATP, releasing energy and creating ADP, adenosine diphosphate. Then your mitochondria recharge the ADP back into ATP using energy from the food you eat. Your body produces and recycles roughly your entire body weight in ATP every single day. It's an endless cycle of chemistry, powering every moment of your life. Fact 56. When you strike a bell and hear that pure, ringing tone, you're hearing the metal vibrate. But here's something interesting about the metal itself. Most metals are made of countless tiny crystals called grains, packed together. The atoms in each grain are arranged in a regular, repeating pattern, but each grain is oriented slightly differently from its neighbors. The boundaries between these grains are where atoms don't quite line up perfectly. These grain boundaries affect how the metal behaves, how it conducts heat and electricity, how strong it is. A bell's tone depends partly on the size and arrangement of these microscopic crystals. Chemistry and physics working together to create sound. Fact 57. Here's something about vanilla, that warm, comforting flavor. Natural vanilla flavor comes from vanilla beans, which contain a compound called vanillin. But vanillin can also be synthesized chemically from wood pulp or even from petroleum products. The synthetic vanillin molecule is identical to the natural one, the exact same arrangement of carbon, hydrogen, and oxygen atoms. Your taste buds can't tell the difference between them because, chemically, there is no difference. The natural vanilla extract tastes more complex only because it contains hundreds of other compounds alongside the vanillin. But the vanillin itself, whether made by an orchid or in a laboratory, is the same molecule. Chemistry doesn't care about its origin story. Fact 58. Let's drift to the Dead Sea, that body of water so salty that nothing can live in it except certain bacteria. The Dead Sea is about 10 times salter than the ocean, around 34% dissolved salts. This happens because water flows into the sea but can't flow out, it only leaves through evaporation. Every time water evaporates, it leaves its dissolved salts behind, and over thousands of years, the concentration has built up to extreme levels. The water is so dense with dissolved minerals that you float effortlessly on the surface. It's chemistry creating buoyancy, a place where the boundary between liquid and solid feels blurred. Fact 59. When you cook an egg, you're witnessing an irreversible chemical change. The proteins in the egg white and yolk are folded into specific shapes when raw. Heat causes these proteins to unfold, or denature, and then tangle together with other unfolded proteins, forming a solid network. This is called coagulation. Once it happens, you can't reverse it. You can't uncook an egg because you can't untangle those proteins and fold them back into their original shapes. It's one of chemistry's one-way streets, a transformation that can only move forward. Fact 60. Here's something about the element phosphorus. There are several different forms of phosphorus, each with different properties. White phosphorus glows faintly in the dark and spontaneously ignites in air, which is why it has to be stored underwater. Red phosphorus is stable and safe, used in the striking strip on matchboxes. Black phosphorus is the most stable form, with a crystal structure similar to graphite. They're all the same element, just with atoms arranged differently. Same atoms, radically different personalities. It's a reminder that in chemistry, arrangement is everything. Fact 61. Let's think about limestone caves, those underground cathedrals formed by chemistry and time. Rainwater absorbs carbon dioxide from the air and soil, making it slightly acidic. This acidic water slowly dissolves limestone rock, which is calcium carbonate. The water seeps through cracks, carving out chambers over thousands of years. When the water drips from the cave's ceiling, some of the carbon dioxide escapes, and the calcium carbonate precipitates out, gradually building stalactites hanging down and stalagmites growing up. It's the same reaction running in reverse, construction and destruction happening simultaneously, patient geology guided by simple chemistry. Fact 62. When you smell the ocean, that distinctive salty, slightly fishy scent, you're not actually smelling salt. You're smelling a compound called dimethyl sulfide, or DMS, produced by phytoplankton and algae in the ocean. When these organisms break down, they release DMS into the air. Seabirds actually use this smell to find food. They've learned that where there's DMS, there's likely to be fish feeding on plankton. So that ocean smell is really the smell of the base of the marine food chain, chemistry announcing the presence of life. Fact 63. Here's a fact about dry ice, that theatrical fog machine in solid form. Dry ice is solid carbon dioxide. Unlike regular ice, which melts into liquid water, dry ice sublimes. It goes directly from solid to gas without passing through a liquid phase. This happens because at normal atmospheric pressure, liquid carbon dioxide can't exist. It only exists as a liquid under high pressure. So when dry ice warms up, it turns straight into carbon dioxide gas, which is denser than air and flows along the ground like fog. It's chemistry skipping a step, a substance that refuses to be liquid unless you force it. The molecules continue their dance, unseen but ever present. Fact 64. Let's think about the graphite in a pencil, that soft black material that leaves marks on paper. Graphite is pure carbon, just like diamond, but arranged in flat sheets stacked on top of each other. The atoms within each sheet are strongly bonded, but the sheets themselves are only weakly connected to each other. This is why graphite feels slippery and why it works as a pencil. When you drag it across paper, thin layers of graphite peel off and stick to the paper's surface. You're writing by leaving behind layers of carbon atoms, just a few atoms thick. Every pencil mark is chemistry at its most elegant and simple. Fact 65. When you blow up a balloon, you're filling it with your breath, which is mostly nitrogen and oxygen, plus about 4% carbon dioxide. But here's something interesting: the balloon doesn't stay inflated forever. Very slowly, the gas molecules inside diffuse through the rubber, escaping to the outside. Helium balloons deflate faster than regular balloons because helium atoms are so much smaller than nitrogen or oxygen molecules. They can slip through the tiny spaces between the rubber molecules more easily. It's chemistry in slow motion, molecules finding their way through barriers we think of as solid, proving that solid things have gaps and spaces at the molecular level. Fact 66. Here's something about the color of blood again, but from a different angle. Blood that's rich in oxygen is bright red because of how oxygen binds to the iron in hemoglobin. Blood that's low in oxygen is darker, more maroon. But blood is never blue, despite what you might have heard about veins looking blue through your skin. That blue appearance is an optical illusion caused by how light penetrates and scatters through your skin. The chemistry of hemoglobin can make blood brighter or darker red, but never blue. It's one of those curious cases where what we see and what's actually there chemically don't quite match up. Fact 67. Let's drift to something cold: snow. Each snowflake is made of ice crystals that form around a tiny particle of dust or pollen in a cloud. As the crystal falls through the cloud, water vapor freezes onto it in layers, always following that hexagonal pattern that water molecules prefer. But the exact shape depends on the temperature and humidity the snowflake encounters on its journey down. That's why every snowflake is unique. Each one traveled through slightly different conditions, and chemistry faithfully recorded that journey in ice. They're all variations on the same hexagonal theme, individual expressions of the same molecular rules. Fact 68. When you taste something sour, like a lemon, you're tasting acids. Acids are molecules that release hydrogen ions when dissolved in water. These hydrogen ions interact with taste receptors on your tongue, triggering signals to your brain that we interpret as sour. Citric acid in lemons, acetic acid in vinegar, lactic acid in yogurt, they all share this property of releasing hydrogen ions. The more hydrogen ions, the more sour the taste. It's direct chemical communication between molecules in your sensory system, acidity translated into flavor. Fact 69. Here's something about natural gas, the fuel that might heat your home or power your stove. Natural gas is mostly methane, a simple molecule with one carbon atom surrounded by 4 hydrogen atoms. It's formed deep underground from the remains of ancient marine organisms that died millions of years ago. Heat and pressure over geological time broke down their complex organic molecules into simpler ones, including methane. When you burn natural gas, you're releasing energy that was originally captured from sunlight by ancient plankton through photosynthesis, stored for eons, waiting underground. It's solar energy from the distant past, preserved in chemical bonds. Fact 70. Let's think about the metal mercury, that strange liquid metal. Mercury is the only metal that's liquid at room temperature. Its atoms don't bond strongly enough to form a solid structure until it gets quite cold, below -39 degrees Celsius. Mercury has been fascinating people for thousands of years because of this unusual property. Ancient Chinese alchemists thought mercury was the key to immortality. We know now that mercury is actually quite toxic, but its chemistry is still remarkable. It's dense enough that iron floats on it, and when you pour it, it forms perfect spherical droplets because of its surface tension. It's chemistry defying our expectations of what a metal should be. Fact 71. When you see dew forming on grass in the early morning, you're watching water vapor from the air condense into liquid droplets. During the night, the grass cools down, and so does the air right next to it. Cool air can't hold as much water vapor as warm air, so the water condenses out onto any available surface. Each dewdrop is a tiny collection of water molecules that were floating invisibly in the air and have now gathered together, visible and glistening. It's the same process that forms clouds, just happening at ground level. Chemistry making the invisible visible, pulled out of the air by temperature and surface and time. Fact 72. Here's a fact about baking soda, or sodium bicarbonate, that humble white powder with so many uses. When you mix baking soda with an acid, like vinegar or lemon juice, it reacts to produce carbon dioxide gas. That's what makes the fizz in fizzy drinks and the rise in certain baked goods. The carbon dioxide bubbles get trapped in batter or dough, making it light and fluffy. Baking soda can also neutralize acids, which is why it helps with heartburn and why it removes odors. Many bad smells are caused by acidic or basic compounds, and baking soda reacts with them to form neutral, odorless salts. One simple compound, so many chemical applications. We drift onward now, through reactions slow and fast. Fact 73. Let's think about the element neon, famous for those bright glowing signs. Neon is a noble gas, which means its atoms are perfectly content on their own and almost never form chemical bonds with other elements. When electricity passes through neon gas in a sealed tube, it energizes the neon atoms, bumping their electrons to higher energy levels. When those electrons drop back down, they release energy as light, in neon's case, that distinctive orange-red glow. Different noble gases produce different colors. Argon glows blue-purple, helium glows pink, xenon glows purple. Each element has its own signature color, determined by the specific energy levels of its electrons. It's chemistry painting with light. Fact 74. When you make caramel by heating sugar, you're doing more than just melting it. Above about 170 degrees Celsius, sugar molecules start to break apart and recombine in new ways, forming hundreds of different compounds. This process, called caramelization, creates that complex, slightly bitter, deeply sweet flavor in that golden brown color. It's similar to the Maillard reaction but doesn't involve proteins. It's just sugar molecules breaking and reforming, building complexity from simplicity through heat and time. The same molecule that tastes simply sweet becomes something rich and nuanced, all because of temperature and chemistry. Fact 75. Here's something about tears, those drops that fall when we're sad or happy or chopping onions. Tears aren't just salty water. They contain proteins, antibodies, and an enzyme called lysozyme that can break down bacterial cell walls. Your tears are actually antibacterial, part of your body's defense system. They also contain oils that help prevent them from evaporating too quickly and keep your eyes lubricated. Every tear is a complex chemical solution, custom-made by your body to protect and clean your eyes. Chemistry caring for you, even in moments of emotion. Fact 76. Let's drift to something ancient, coal. Coal formed from the remains of plants that lived and died in swamps millions of years ago. Layer upon layer of plant material built up, and over time, heat and pressure from overlying sediments squeezed out moisture and volatile compounds, concentrating the carbon. The process took millions of years. The youngest coal is brown and crumbly, still containing a lot of water and other compounds. The oldest coal is hard, black anthracite, almost pure carbon. It's a spectrum of transformation, plants slowly turning to rock, their stored solar energy compressed and waiting. When we burn coal, we're releasing sunlight that fell on ancient forests, chemistry spanning geological ages. Fact 77. When you polish tarnished silver with baking soda and aluminum foil in hot water, you're not just scrubbing the tarnish off. You're actually performing electrochemistry. The aluminum gives up electrons more easily than silver, so the silver sulfide on the tarnished silver reacts with aluminum, pulling the sulfur away from the silver and onto the aluminum instead. The silver returns to its shiny metallic state while the aluminum gets a bit of tarnish. It's a chemical trade, sulfur moving from one metal to another, facilitated by the ions in the baking soda solution. You're not removing the tarnish, you're chemically reversing it. Fact 78. Here's something about the element iodine. Most elements are either metals or nonmetals, but iodine sits right at the boundary. At room temperature, it's a dark purple-gray solid that sublimes directly into a beautiful purple vapor when heated. Your body needs tiny amounts of iodine to make thyroid hormones, which regulate metabolism. Before iodine was added to table salt in the 1920s, iodine deficiency was common and caused thyroid problems. Now, that tiny amount of iodine in salt prevents these issues. It's chemistry on a trace scale, just a few micrograms a day making the difference between health and disease. Sometimes the smallest amounts matter most. Fact 79. Let's think about spider silk for a moment, one of nature's most remarkable materials. Spider silk is a protein, made of chains of amino acids. But the way these proteins fold and align gives the silk incredible properties. It's stronger than steel by weight, yet elastic enough to stretch significantly before breaking. Different spiders produce different types of silk for different purposes, some for web structure, some for wrapping prey, some for safety lines. The chemistry is in the protein sequences and how they crystallize and align. Spiders are master materials scientists, spinning chemistry into threads strong enough to catch flying insects. Fact 80. When you see green copper roofs on old buildings, like the patina on the Statue of Liberty we mentioned earlier, that green layer is actually protecting the copper underneath. The patina is made of copper carbonate and copper sulfate, formed by reactions with carbon dioxide, water, and sulfur compounds in the air. Once this layer forms, it's very stable and prevents further corrosion of the copper beneath. Ancient peoples didn't understand the chemistry, but they knew copper lasted nearly forever outdoors. Roman copper pipes are still intact after 2,000 years, wearing their protective green coats. Its chemistry is armor, one reaction preventing all the others. Fact 81. Here's a fact about chlorophyll, that crucial green pigment in plants. Chlorophyll molecules have a structure similar to hemoglobin in your blood. Both have a ring structure with a metal atom at the center. In hemoglobin, it's iron. In chlorophyll, it's magnesium. Both molecules capture and transfer energy. Hemoglobin carries oxygen, chlorophyll captures light. It's as if life used the same basic molecular design for two completely different but equally essential jobs. The same architecture, different metal, different purpose. Chemistry economizing, using one good design in multiple ways. And so the story continues, written in atoms and bonds. Fact 82. Let's think about something delicate, the bubbles in champagne or sparkling water. Those tiny bubbles are carbon dioxide gas coming out of solution. The gas was dissolved in the liquid under pressure, and when you open the bottle, the pressure drops and the gas escapes. But the bubbles don't form randomly throughout the liquid. They need a nucleation site, a tiny imperfection or dust particle or scratch on the glass where the gas molecules can gather and grow into a bubble. This is why champagne flutes often have a small etched point at the bottom, to create a steady stream of bubbles. Without those nucleation sites, the carbon dioxide would escape much more slowly. Chemistry needs a starting point, a place to begin. Fact 83. When you burn wood in a fireplace, the smoke you see is actually tiny particles of unburned carbon and other compounds suspended in hot gases. If combustion were perfectly efficient, you'd see no smoke at all, just invisible carbon dioxide and water vapor. But real fires are messy, and some of the wood doesn't burn completely. Those smoke particles scatter light, which is why smoke is visible. When smoke cools, those particles settle as soot. Chimney sweeps used to climb inside chimneys to remove this buildup, this chemistry of incomplete combustion that accumulates over time. Clean burning is about chemistry being efficient, turning fuel into the simplest possible products. Fact 84. Here's something about the element fluorine. It's the most reactive element known, so aggressive chemically that it can make things burn that you'd never think could burn: water, sand, even asbestos. Fluorine is so reactive because its atoms desperately want to gain one more electron to complete their outer shell. When combined with other elements, though, fluorine forms some incredibly stable compounds. Teflon, that non-stick coating on pans, is a fluorine compound so stable that almost nothing reacts with it. The most reactive element creating the most unreactive material. It's one of chemistry's beautiful contradictions. Fact 85. Let's drift to something sweet and sticky: honey crystallizing. Sometimes honey that's been sitting in your cupboard will start to form crystals and become grainy. This happens because honey is a supersaturated solution of sugars, mainly glucose and fructose. Over time, glucose molecules start to come out of solution and form crystals. This doesn't mean the honey has gone bad. Remember, honey never spoils. You can gently warm the honey and the crystals will dissolve again. Some honeys crystallize quickly, others stay liquid for years, depending on their ratio of glucose to fructose. It's chemistry expressing itself in texture, the same substance in different forms. Fact 86. When you smell freshly cut grass, that distinctive green scent, you're smelling chemicals called green leaf volatiles. Plants release these compounds when their tissues are damaged, as a wound response. These chemicals serve multiple purposes. They can attract predators of the herbivores eating the plant, they can signal to other parts of the plant to prepare defenses, and they can even communicate with nearby plants to warn them of danger. That pleasant smell is actually a chemical alarm system, a cry for help broadcast in molecules. Chemistry is language, plants speaking to each other and to the insects around them in scent. Fact 87. Here's something about the metal titanium. It's as strong as steel but about 45% lighter, and it's remarkably resistant to corrosion. When titanium is exposed to air, it instantly forms a thin, tough layer of titanium dioxide on its surface. This oxide layer protects the metal beneath from further corrosion. The same compound, titanium dioxide, is used as white pigment in paint and sunscreen. It's harmless and incredibly stable. This is why titanium is used in medical implants. Your body won't reject it, and it won't corrode. It's a metal that lives comfortably at the boundary between the mechanical world and the biological one, thanks to that protective oxide skin. Fact 88. Let's think about the process of ripening fruit. When fruit ripens, it's undergoing a cascade of chemical changes. Starches convert to sugars, making the fruit sweeter. Chlorophyll breaks down, revealing other pigments and changing the color. Acids decrease while aromatic compounds increase, changing the flavor and smell. Cell walls soften as the pectin holding them together breaks down. Many fruits also produce ethylene gas, which triggers and accelerates ripening. This is why one rotten apple spoils the barrel. The ethylene from the overripe fruit triggers ripening in the others. It's chemistry in conversation, one fruit speaking to another in molecules, coordinating their transformation. Fact 89. When you look at a flame and see it dancing and flickering, you're watching hot gases rising and cooler air rushing in to replace them. But there's more to it than just air movement. Combustion reactions produce heat, and that heat creates more combustion in a feedback loop. The flame is self-sustaining as long as there's fuel and oxygen. But flames are also influenced by tiny air currents, by the geometry of the fuel, by moisture content. Each flame is unique, a temporary structure built from chemistry and physics, existing in that narrow zone where fuel, oxygen, and temperature all meet in the right proportions. Fact 90. Here's something about the element calcium. It's the most abundant metal in the human body, making up about 2% of your total body weight. Most of it is in your bones and teeth, providing structure and strength. But calcium ions also play crucial roles in muscle contraction, nerve signaling, blood clotting, and countless other processes. Your body carefully regulates calcium levels in your blood, pulling it from your bones if necessary to maintain the right concentration. Its chemistry is architecture and signaling both, the same element serving multiple essential functions. Structure and message combined in one atom. Fact 91. Let's think one more time about water, that molecule we've returned to again and again. Water has a property called high specific heat, meaning it takes a lot of energy to change its temperature. This is because of all those hydrogen bonds between water molecules. They have to be partially broken before the water can get warmer. This property makes water an excellent temperature regulator. Your body is about 60% water, and all that water helps keep your temperature stable. Oceans absorb and release heat slowly, moderating Earth's climate. Lakes and rivers do the same on a smaller scale. Water's chemistry makes it a buffer against temperature extremes, protecting life from the harshness of rapid change. And now we approach the end of our journey, these final facts. Fact 92, let's think about something gentle, the element lithium. It's the lightest metal, so light it floats on water. Lithium is used in batteries because its atoms readily give up their electrons, and those electrons can flow as electrical current. But lithium also has medical uses. In small, controlled doses, lithium compounds help stabilize mood in people with bipolar disorder. Scientists still don't fully understand exactly how it works in the brain, but it affects neurotransmitter signaling and helps regulate the chemical messages between neurons. One of the simplest metals, helping to balance the most complex organ in the body. Chemistry touching the mind itself. Fact 93, when you watch clouds drifting across the sky, you're seeing water in yet another form. Clouds are made of tiny water droplets or ice crystals suspended in air, so small that air currents can hold them aloft. Each droplet forms around a tiny particle of dust or salt or pollen. The water molecules gather around these nuclei, growing larger but still light enough to float. When enough droplets combine and grow heavy enough, they fall as rain. The entire water cycle, evaporation, condensation, precipitation, is chemistry cycling endlessly between earth and sky, the same molecules rising and falling for billions of years. Fact 94, here's something about the element nitrogen again, but in a different context. About 78% of the air is nitrogen gas, but most living things can't use it in that form. The nitrogen atoms in N2 molecules are held together by a very strong triple bond. Only certain bacteria can break this bond and convert nitrogen into forms that plants can use, a process called nitrogen fixation. These bacteria often live in the roots of plants like beans and clover. Without them, without this quiet chemistry happening underground, most life as we know it couldn't exist. It's chemistry performed by the smallest organisms, making possible the existence of the largest. Fact 95, let's drift to something warm, the element sulfur. Sulfur has been known since ancient times and was once called brimstone. It burns with a blue flame and produces sulfur dioxide, that sharp smell associated with matches and volcanoes. But sulfur is also essential for life. It's in 2 of the amino acids that make up proteins, and it's in some vitamins. The disulfide bonds between sulfur atoms help proteins maintain their 3-dimensional shapes. Your hair gets its shape partly from these sulfur bonds, which is why permanent waves and relaxers use chemicals that break and reform these bonds. Structure built from sulfur, chemistry creating form. Fact 96, when you blow out a candle and see that thin trail of smoke rising, you can sometimes relight the candle by holding a flame to that smoke trail, even an inch or 2 above the wick. This works because that smoke contains vaporized wax that hasn't yet cooled and condensed. The flame travels down through these wax vapors back to the wick. It's a visible reminder that combustion happens in the gas phase. The solid wax has to melt and then vaporize before it can burn. What looks like solid burning is really vapor burning, chemistry happening in states we can't always see. Fact 97, here's something peaceful about the noble gases we mentioned before. They're called noble because they don't readily react with other elements, like nobility standing apart. Helium, neon, argon, krypton, xenon, radon, Each one is content with its electron configuration and feels no need to form bonds. This makes them stable, predictable, safe. We use argon in light bulbs because it won't react with the hot filament. We use helium for balloons because it won't burn. These elements teach us that sometimes stability comes from being complete in yourself, from not needing anything else. Chemistry as philosophy. Fact 98. Let's think about the concept of a catalyst one more time. A catalyst is a substance that speeds up a chemical reaction without being consumed by it. Enzymes in your body are biological catalysts, helping reactions happen millions of times faster than they would on their own. The catalyst provides a different pathway for the reaction, one that requires less energy to start. After the reaction, the catalyst is unchanged and ready to work again. Its chemistry is facilitation, helping transformations happen without being transformed itself. Presence without participation, guidance without sacrifice. Fact 99. When you look up at the stars on a clear night, you're seeing chemistry across vast distances. The light from those stars was produced by nuclear fusion, hydrogen atoms joining to form helium in the hearts of distant suns. That light travels for years, sometimes centuries or millennia, across empty space. When it finally reaches your eye, it triggers a chemical reaction in the photoreceptor cells of your retina, sending signals to your brain. Chemistry at the start of the journey, chemistry at the end. The universe speaking to you in light, and your body listening in molecules. Fact 100. And so we arrive at our final fact, and perhaps the most peaceful one of all. Every element in your body except hydrogen was made inside a star. The calcium in your bones, the iron in your blood, the carbon in your cells, the oxygen you breathe, all of it was forged in the nuclear furnaces of stars that lived and died billions of years ago. When those stars exploded as supernovas, they scattered these elements into space. Those atoms drifted through the cosmos, eventually gathering into the cloud that became our solar system, our Earth, and eventually, you. You are not just connected to the universe, you are made of it. You are stardust, assembled by chemistry into someone capable of wondering about chemistry. You are the universe experiencing itself, through the quiet miracle of atoms arranged just so. And with that thought, let yourself rest. Let the chemistry of sleep take over, your neurons quieting, your muscles relaxing, your breathing slowing. All of it guided by molecules, by reactions, by the gentle dance of atoms that never stops, even in your deepest dreams. Chemistry surrounds you, supports you, and is you. Rest now in that knowledge. Rest in the quiet certainty that you are part of something vast and ancient and continuing. Good night.